Mercedes-Benz SRS, or Supplemental Restraint System, is a critical safety network that protects occupants during collisions. Understanding how this system works and what can go wrong is essential for proper maintenance. The SRS system consists of five main components working together. The SRS control unit acts as the brain, crash sensors detect impacts, airbag modules deploy during collisions, seatbelt pretensioners tighten belts instantly, and the clock spring maintains electrical connections in the steering wheel. Modern Mercedes models from 2024 and 2025 feature advanced diagnostic capabilities. Enhanced OBD3 integration provides real-time monitoring, while wireless diagnostic updates can identify issues before warning lights appear. Key SRS components include the control unit, which processes all safety data, crash sensors that detect impact forces, and the clock spring that maintains steering wheel connections. Each component plays a vital role in system reliability. Common SRS fault codes help technicians identify specific problems. B1000 indicates control unit issues. B1050 points to driver airbag circuit problems often caused by clock spring failure, and B1055 suggests passenger airbag circuit faults typically from seat sensors. Recent trends show increased sensitivity in SRS fault detection due to updated safety standards. There has been a 15% rise in SRS-related recalls from 2020 to 2024, primarily involving clock spring and seat sensor issues. Understanding these patterns helps predict and prevent common failures. Understanding Mercedes SRS system components, modern diagnostic capabilities, and common fault patterns provides the foundation for effective troubleshooting and repair. This knowledge is essential for maintaining the safety systems that protect vehicle occupants. Proper diagnosis of Mercedes SRS faults requires four essential tools, each serving a specific purpose in the diagnostic process. First, the Mercedes Zentry, or DAS diagnostic software, provides official access to SRS fault codes and system parameters. This professional-grade software is essential for accurate diagnosis. Second, an oscilloscope analyzes communication signals between SRS components. This tool helps identify network communication failures that standard scanners might miss. Third, a high-impedance multimeter safely measures SRS circuit voltages without damaging sensitive components. Standard multimeters can cause airbag deployment and must never be used. Fourth, airbag simulators replace actual airbag modules during testing, allowing circuit verification without the risk of accidental deployment. Safety protocols are critical when working with SRS systems. Three essential safety steps must always be followed to prevent injury and component damage. Two major case studies demonstrate common SRS failures in Mercedes vehicles. The W205 C-Class clock spring epidemic affected over 180,000 vehicles worldwide. The second major issue involved GLE-class seat occupancy sensors providing false readings, requiring both software updates and sensor recalibration to resolve. SRS repair costs vary significantly based on the component and complexity. Diagnostic fees typically range from $150 to $250, while component replacements can cost much more. The future of SRS repair includes predictive maintenance systems that can forecast component failures up to 6 months in advance, and component standardization across Mercedes model lines by 2027. These advances will reduce repair complexity, improve diagnostic accuracy, and make SRS maintenance more accessible to independent repair facilities.